Alright, welcome to question 3, and in this question we are aiming to try and be fast enough. So we have a question here. We are told in each of the following cases determine the magnitude and the direction angles of the resultant. So in the first one we have these 3 forces, okay? So we need to determine the magnitude and the direction angles. So for the first one, we see we can get, from what we are given here, we see you can get angles. You can get either this, like this angle, you can get this angle, you can get this angle, and then with those angles you'll be able to resolve the components, okay? The other way is to just use the dimensions as they are, and you use Pythagoras theorem, you get the hypotenuse for each of these, okay? By using the Pythagoras theorem, you'll be able to get the hypotenuse of each, which is maybe a little bit more tedious. So we'll just use the tangent function to get the angles, isn't it? Right. So I'll start with getting the angle, which I'll name, what's the name? Let's just call them phi. So the phi, I'll start with phi. Phi A. Now phi A meaning that angle, and then it is originating from the x. So phi AX, hope that is phi, I hope so. This will be the tan inverse of, from what I'm seeing, it will be 130 over 120. 130 over 120. Okay. And then phi B, and it also originating from the x. This will be tan inverse of 240 over 120. The 120 is this distance here, okay, and this, right, okay. So this will find the answer, and then the phi C, let's make it originate from the y as labeled. This will be tan inverse over 180 over 90, which we'll find there. Okay. So if you do the calculation well, let me punch on the calculator. I think this will take long, so maybe I have to skip this part. Alright. Okay. So now this is 47.29 degrees. This is 63.43 degrees. And again, this is 63.43 degrees. Yeah. Tan inverse of 2. Yeah, tan inverse of 2. Okay. Having done that, having gotten the angles we need as labeled here, these angles as shown there on the diagram, we'll now be able to get our components. Let's say the resultant force we'll say, without even sort of getting we can just go straight forward, adding the the force. We can be able to get the forces now in their respective vector components. So we know that our FA, we call it FA as a vector, is equal to what? Is equal to 80, 80, that's a magnitude. The x component is cos. Yes, 80 cos 47.29. Okay, this is our I, and then plus actually it's minus because I've seen the y component is going in that other direction and it has no z component, so it will be 80 sine 47.29 degrees. Okay, and this is J. So that's our FA. Our FB is also just like the same, will be 100 cos 63.43 degrees plus 100 sine 63.43 degrees. This is J, that's I. And our FC as a vector is equal to that will be the J and the K. So on the K, the J is equal to 75 cos 63.43 degrees J, and then plus 75 sine 63.43 degrees K. Alright, so to get the answers, you will just sort of get the components of each, and you've got your answers. It is that simple. So you add the i's alone. So for the i's, we just have to add there. So anyway, let's do it. So then we are saying, sorry about that. Now you can skip some of these steps, but you just have to be cautious. So FR is equal to FA, okay, plus FB plus FC, isn't it? We know that. Let's go to the other side and complete this. Okay, I'm not going to resolve cos whatever times 80 is this, cos whatever times this is this. No, but I know that For frx, I'll just have to add this I and the I for fb. They are just two i's. fc does not have the I. Okay, so I'll have frx is equal to, I know I have fax and plus fbx, which you already know, well, the I. So together they are giving me 98.99 newtons. Fry will be equal to, again, you add the three of them. Okay, so remember that for the FA, the y component is negative 80 sine 47.29, then plus 100 sine 63, and then plus 75 cos. So when you add those, like you have, okay, this thing, you have F, okay, so FRY is equal to FA y plus FBY plus FCY, and if you add those, you should get yourself 64.20. Yes, 64.20 Newton. FRZ is equal to, again you add, in this case you have only one component, is the Z, and that is FC sine 63.43, and that should give you 67.08 newtons. Okay, like this, we see already now that we'll have our F in Cartesian vector form. It will be F will be equal to 1998.99 I plus, in this case we have 64.2 J plus 67.08 K, and you put it in brackets, you factor out the Newton. So this is your FR, your resultant. Okay, so that is how we solve that. Sorry, the writing isn't very neat, but we should be able to see if we are following through. If you are not following through, oh, sorry, so sorry, it's hard to write on the touch screen, and we'll get the proper tools soonest. Okay, let's move on. So we'll have to actually, we need some space to do the other. So we'll try to see if we can delete. This deleting will take long. Okay. We'll just mark the answers. Okay. We've marked them. So I'll just, I've just marked this. We've seen where we are coming from. So I'll just erase everything here. Come on. Really? Ooh. Okay. Now, what we are told is to determine the direction cosines. Alright, so I need to determine the magnitude. So I know that FR, the magnitude now, is equal to the square root of those components I got. 98.99 squared plus 64.2 squared plus 67.08 squared. And this, if you haven't made any mistake, or I don't know if it's me who has made a mistake, you should have 135.72 newtons. Okay. So then our alpha is equal to cos inverse of 98.99 over 135.72. Our beta is equal to cos inverse of 64.2 over 135.72, which is equal to it. And our gamma is also equal to cos inverse of 67.08 over 135.72. And these, you get your answers there. If you did so, you have 43.2 degrees, and then you have 61.8 degrees, and then you have 60.4 degrees. So for angles, usually it seems advisable to leave it to one decimal place, but I personally will not penalize you if you leave it at 2 decimal places. So that's how you solve this question. Thank you.